There are times when you may need to take various different actions according to the value of some variable in your code. Here's a simple example. I've decided I want to write a program that shows the characters defined by the ASCII codes from 0 to 127. Every character you enter on the keyboard or which is read from a file can be represented by a numeric code. The first 128 are standard characters, things like A, B, C, numbers, and so on. And then above those values you get into the realms of non-standard characters, graphics, and in fact these days you have even larger ranges of characters to represent all the different characters from different languages, Chinese, Japanese, Hindi, Arabic, and so on. But for simplicity here I'm going to stick to the limited set of the first 128 characters of the standard ASCII table. Now the standard alphabetic characters have codes from, and you can see them here, 65 for the capital A up to the value of 90 for capital Z. And then lowercase characters start at 97 and go up to 122 for lowercase z, and there are also ASCII codes to represent the numeric characters 0 to 9. They happen to be, let me scroll up here, you can see 0 on the right is represented by code 48, 9 by the code 57. And there are also special characters such as tab, that's got code 9, line feed, which is represented by code 10, and so on. Now, in order to show these characters, in this, my first effort, I've written a for loop, and it counts from 0 up to 127, incrementing the loop variable I at each turn, and it calls this find char type function, and it passes to it the value of I at each turn through the loop. And then this function up here, it has a complicated set of if-else-if tests, which tests the value of I, and it then assigns a string describing what sort of character is represented by that value in the ASCII table. So if it's got a value of 0, that's the code for null. If it's got a value of, I've got a mistake here, it should be 8, that's the value for backspace. 9 is tab, and so on. And then I go up to this section down here, which does a test. If it's greater than or equal to 48, or less than or equal to 57, then it's a number. Otherwise, it's just some sort of standard character. But there's an alternative, a neater and in some cases more efficient way of doing these kinds of tests. I could do this by writing a switch statement. And you can see an example of a switch statement in 02_switch case. That's a project supplied in the source code archive from step 5. A switch statement lets you run different bits of code according to the value of a specific variable such as I here. In this statement, this code runs when I is 0, and so the string null is assigned to the variable char type. This code runs when I is 7, and so bell is assigned, and so on. Now let me explain the syntax. A switch statement begins with the keyword switch, followed by a test value, and here that's I. This test value must be an integer or some piece of data, such as a char, that can be treated as an integer. Then you write one or more case statements, each of which specifies a value that is compared with the test value. If a match is made, that is, when the case value and the test value are the same, the code following the case section and a colon execute. Now, when you want to exit the code in a case block, you need to use the keyword break. If case tests are not followed by break, sequential case tests will be done one after the other until break is encountered. You can see an example of that here. Let's imagine that, for example, I is 51. Then this case is matched, but because there's no break, the code trickles down through all the other case tests. And of course, no match is made in these cases because a match has already been made with the value 51. But finally, I hit this assignment, and so this piece of code here is executed, and the char type variable is assigned the string number. And only then is this break hit, and execution then breaks out of the bottom of the switch block. In other words, by putting this sequence of case tests with no break statement, when the test variable I has any value between 48 and 57, then this is the code that executes. And so the assignment here is made with any of those values, and then the code breaks out of the switch block. And you can also optionally, as I've done here, specify a default, and that will execute if no match is made by any of the case tests before it. As I've said, the default section is optional. You don't have to put it there, but if you put it there, then that's the behavior that will occur. Now note I've also put a break statement in the default section. Strictly speaking, you don't need to put a break after default, but it's generally considered to be good practice to do so. Apart from anything else, if someone subsequently puts some more case tests after the default, and that is allowable in C, then the presence of the break here will make sure that the code execution doesn't accidentally carry on trickling down through the code after you'd intended it to stop.